So here we're going to solve the systems algebraically, and that's when we set the equations equal to each other. We want to find when are the functions equal to each other because that's when they intersect. So the two functions will reach that same function value at that x value. In this case, we have a parabola x squared minus 5x plus 6, which is f of x, and I'll highlight that. Use it. Go. And then we have g of x, which is linear, 3x minus 6, right? And we're setting them equal to each other. All right, so we have a quadratic equal to a linear function. So what we want to do, this is since the largest degree would be 2, we want to set this equal to 0 since it's quadratic. So what you're going to want to do is bring the 3x and negative 6 over to the left-hand side. We're trying to set that equation equal to 0. So I'll do it one at a time. We subtract 3x on both sides. We'll get x squared, and then the like terms would be negative 5x minus 3x. That would be negative 8x. And then bring everything down. All right. Now we're going to add the 6 over. And that way we get 0 over here. So we have x squared minus 8x plus, and then 6 plus 6 is 12. The two constant terms combined to get 12. So right now we have a quadratic, x squared minus 8x plus 12 equals 0. Okay, so we're trying to find what x value or x values will this be true when x squared minus 8x plus 12 equals 0. So you want to think, what are our methods for solving quadratic equations? Well, first you want to check for a GCF. Is there any GCF we can take out? Well, not in this case. 1 would be the only common factor between the quadratic, linear, and constant term. So now you want to look at your factoring methods. Okay, so let's see. Can we factor this guy? If we can, we're going to want to do that. But if we can't, we can always use our friend, the quadratic formula. So let's first see if this can be factored. So what I'm going to do is I'm going to find the factors of 12, which is 1, 2, 3, 4, 6, and 12. And I want to figure out which two numbers multiply to give me 12, but also combine to give me that middle linear coefficient, negative 8. All right, so 1 and 12 obviously can't work. Let's look at 6 and 2. 6 plus 2 is 8, but we need a negative 8. All right, so how can we combine 2 and 6 to give us a negative 8? Well, we would just make both of those negative, right? So let's see. So I'm going to start off x and x to give us our x squared term. And then we know that the factors have to include a 2 and a 6. Now we just have to determine the sign of them. So negative 2 minus 6 is negative 8. And negative 2 times negative 6 is positive 12. So those would be the two factors that work. Okay? So just to be clear, this guy and this guy, they are equivalent, right? It's just going from standard form of a quadratic to factored form. And that's how we're going to solve this quadratic equation. All right, so now we are going to use the zero product property, which states that if I have two factors multiplying to give me 0, one of those factors has to be 0, right? So I'm going to take each factor. So the first factor would be x minus 2, set that equal to 0. And then the other case could be x minus 6 equals 0, right? So I'm just branching them off, setting them both equal to 0. All right, so now I'm just going to solve these linear equations. Well, what number minus 2 is 0? Well, that has to be 2. So one of our solutions will be x equals 2. And then over here, what number minus 6 is 0? That is 6. So our x points, the x coordinates at the point of intersection are 2 and 6. So now we don't have the y value, right? We have the x coordinates. So if the question only asks for that, that's all you need to give. But if you want to find the y-coordinates, there's a really easy way to do this. All right, so since the functions f of x and g of x are equal at these two x values, we can substitute these numbers into either equation f of x or g of x to find the corresponding output for these inputs. So you kind of want to think about what is the easiest equation to work with, and I'm going to say it's the 3x minus 6. So what we can do is if we find g of 2, right, to find the output, it would be 3 times x minus 6, so 3 times 2 minus 6, which is 6 minus 6, which is 0. So g of 2 is 0, meaning that for the input of 2, 0 is the output. So there is one point of intersection. All right, let's use g again. You could also use f if you want to have some fun, but let's just use g of x. So find g of 6, which would be 3 times x minus 6, so 3 times 6 minus 6. 3 times 6 is 18. 18 minus 6 is 12. All right, so g of 6 is 12. So for the input of 6, we get back out an output of 12. So there's our other point of intersection. And that's how you solve a system algebraically. And this is specific for one quadratic and one linear function.